Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Minister of Aeronautical Engineering, Dundigal, Hyderabad. In this session, I would like to present differential equations of second and higher order with constant coefficients. Especially, I want to concentrate on the particular integrals in some special cases. In the previous video, we have calculated the particular integrals by using the general procedure, by using the general method. But it is a very complex procedure to find the particular integral. But in some cases, we can find the particular integral very easily based on the function q of x. So here, I am going to explain about the type 1 particular integral finding method, that is finding of particular integral of f of d of y is equal to q of x, where q of x is equal to e power ax. So this is the type 1. So in this, we have various types, type 1, type 2, type 3, type 4 and type 5. These are all, we call it as a shorter methods to find the particular integral. Instead of using the conventional method, by using the definition, we can find the particular integral very easily instead of the complex procedure. So in this type 1, we are going to find out the particular integral of f of d of y is equal to q of x, where q of x is equal to e power ax notation. So in this, yp is equal to 1 by f of d of e power ax. So to find yp, just you replace d by a if f of a is not equal to 0. Very simple procedure we are following. The working rule is to find the value of yp, 1 by f of d of e power ax, just replace d by a if f of a not equal to 0. If f of a not equal to 0, the value will become e power ax by f of a. Suppose if you replace d by a, if f of a is equal to 0, then yp is 1 by f of d of e power ax. Yp means particular integral of y. 1 by f of d of e power ax is equal to, suppose if f of d is expressed in the form 1 by d minus a whole power k of e power ax, then the value will be x power k by k factorial into e power ax. So here we are crossing the two situations, when it is not equal to 0, when it is equal to 0. When not equal to 0, the value is e power ax by f of a. Very simple. If f of a 0 and f of d is in the form d minus a whole power k, then 1 by f of d of e power ax is x power k by k factorial into e power ax. So to find the solution of f of d of y is equal to q of x, so we have seen already the solution will be the complementary function plus particular integral. So we know how to find the complementary function. So this is all based on the roots of the equation. We can write yc, and yp, if it is function e power ax, then we can find easily by using this method. So we will see some examples when the right hand side function is e power ax or constants or cos hax or sin hax, because all those represent in the terms of e power ax and e power bx, etc. So now I will solve an example. Solve the differential equation d square y by dx square plus 5 dy by dx plus 6y is equal to e power ax. Clearly, the right side function is e power x, so we can find the particular integral by using simple method. Instead of going for a general method, we can go for the simple procedure, that is called the shorter methods. So first, find the complementary function. The equation can be written in our operator form as d square plus 5d plus 5 plus 6 of y is equal to e power x. So where what is d? D means d by dx. And what is d square? D square by dx square. So that I can write it as d square plus 5d plus 6 of y is equal to e power x. So here what is f of d? This is in the form f of d of y is equal to e power x notation. So here f of d means d square plus 5d plus 6. Now the auxiliary equation will be f of m is equal to 0. F of m means replace d by m simply. Then equation will be m square plus 5m plus 6 is equal to 0. So on finding the roots and based on the roots of the equation, we are going to write the complementary function. So on writing in factor notation, m square plus 5m can be written as 3m plus 2m plus 6 is equal to 0. And multiplying, you'll get 6m square. So m on taking out m plus 3 plus 2 of m plus 3 is equal to 0, or m plus 3, m plus 2, 0, or m values are minus 3 comma minus 2. So what is the nature of the roots? The roots are real and distinct. So the complementary function will be in the form c1 e power minus 3x plus c2 e power minus 2x. So this already we have solved many problems. Finding of f of d into y is equal to 0 solution. That will be the first part of the solution of f of d into y is equal to q of x. Now the second part is find the particular integral. So the particular integral is equal to yp is equal to 1 by f of d of e power x. So here f of d is d square plus 5d plus 6 of, so the right side function is clearly it is e power x. So this is e power x. So just replace d for here 1 by f of d of e power ax notation. Just replace d by a, that means e power ax by f of a, when f of a not equal to 0. So if f of a not equal to 0, the particular integral is e power ax by f of a. Very simple. So just replace d for 1. Here a is equal to 1. Am I right or not? E power ax means a is 1. Replace d by 1. 1 plus 5 into d is also 1 plus 6. That means 1 by 1 plus 5 plus 6. That is equal to 12. That is e power ax by 12. Because the denominator is not equal to 0. If it is 0, then we go for the another model, another form. So e power x by 12 is the particular integral, that is yp. Therefore, the complete solution y is equal to complementary function plus particular integral, that is y is equal to c1 e power minus 3x plus c2 e power minus 2x complementary function, and particular integral is e power x by 12. So in this way, we can find the particular integrals very easily based on the function q of x. Based on the function q of x. In type 1, we are going through if the function is e power ax. So the methodology we have followed up here, and we get easily the particular integral, and the complete solution will be y is equal to complementary function plus particular integral. So similar way we solve another problem. Here also the equation already given in operator form, d square plus 2d plus 1 of y is equal to e power minus x plus 3. So the right side is e power minus x notation, e power ax notation, and 3 also you can write it as 3 into e power 0x. 3 also I can write 3 into e power 0x. So I can apply for both terms e power ax notation. So as usual, first find the complementary function. The f of d is here d square plus 2d plus 1. The roots are m square plus 2m plus 1 is equal to 0. So clearly it is m plus 1 whole square. So m square plus 1 plus 2m 0, or m plus 1 0. The roots are minus 1 minus 1. So the roots nature is real and equal. So the complementary function will be cf is equal to c1 plus c2x into e power minus x. Because the roots are distinct in the previous example, that is c1 e power minus 2x plus c2 e power minus 3x. Like that we have written. But here the roots are one and the same. The roots are real and equal. When the roots are equal, the notation will be in the form c1 plus c2x into e power minus x. So this is the first part of the solution, complementary function. Now we need to find the particular integral. What is particular integral? That is yp, that is 1 by, I will show in the next slide. The particular integral is given by yp is equal to 1 by d square plus 2d plus 1 of e power minus x plus 3. So here we have to operate the function 1 by d square plus 2d plus 1 on two functions. One is on e power minus x and the second one is on 3. So I can split this 1 by d square plus 2d plus 1 of e power minus x is one term plus 1 by d square plus 2d plus 1 of 3. So 3 can be written as 3 into e power 0x in the next step. And this can be written as, if you put d in place of d minus 1, it is minus 1 whole square, that is plus 1 minus 2 into d plus 2 into minus 1. That means what? Minus 2 plus 1. The denominator will be 0. So when the denominator 1 by f of d of e power ax is equal to, when you replace d by a, if it is 0, then we write the denominator in the form 1 by d minus a whole power k of e power ax notation. Then the formula will be x power k by k factorial into e power ax. As you seen earlier in the working rule, the formula will be x power k by k factorial into e power ax. So here when you replace d for minus 1, the denominator is 0. So I am writing this whole thing as 1 by d minus of minus 1 whole square. 1 by d minus of minus 1 whole square. 1 by d minus a whole power k of e power minus x notation. So what is the formula for this? X power k. K means 2. K means here k, this is 2. K is equal to 2 by 2 factorial of e power minus x. This is the x square by 2 factorial into e power minus x. So on replacing d for 0, here the function is e power 0x. On replacing d for e power 0x means 0. 1 by 0 plus 0 plus 1. So it is not equal to 0. The denominator is not equal to 0 means the value will be 3 by 1, that is equal to 3. So the particular integral will be x square. 2 factorial means 2 into 1, that is 2 e power minus x as it is, plus 3 by 1 into e power 0x again 1, that is 3. So this is the particular integral of the given differential equation of the form f of d into y is equal to e power ax notation. Therefore, the complete solution is given by complementary function plus particular integral, that is c1 plus c2x of e power minus x plus x square by 2 e power minus a plus 3 is the required solution of the given differential equation. So when e power ax, you please keep in mind the formula. When d, if you replace d by a, if it is not equal to 0, the value is e power ax by f of a. If we replace d for a, if it is 0, then 1 by d minus a whole power k of e power ax is equal to x power k by k factorial into e power ax. That is the simple way to find the particular integral when the function is e power ax. So now we will solve one example. Here we have the problem: solve the differential equation d minus 1 whole square of d plus 2 of y is equal to e power minus 2x. So you can observe that the right hand side is in the notation e power minus 2x. So this equation will have the solution as the complementary function plus particular integral. So what is here f of d? What is here f of d is d minus 1 whole square of d plus 2 also. Therefore, the auxiliary equation is given by m minus 1 whole square of m plus 2 is equal to 0. That means what are the roots? M minus 1, m minus 1, m plus 2 is equal to 0. M minus 1 repeated 2 times. So what are the values? 1, 1, minus 2. So it is a third degree equation. There exist 3 roots. So what is the complementary function? Therefore, the complementary function yc. So here 1 is repeated twice. So for this, what will be the complementary function? c1 plus c2x of e power x. That is the term used for 1, 1 roots. And for third root, minus 2, it is a different root. So I use the constant as c3 e power minus 2x. Or you can write like this also. First yc is equal to c1 e power minus 2x plus c2 plus c3x of e power x. So both ways you can represent. Here the first taken 1 roots, repeated roots. Here first taken minus 2 root c1 e power minus 2x plus this thing. So this is the first part of the solution. Now we have to find the particular integral. Now the particular integral, the pi, is yp is equal to, what is the here, 1 by d minus 1 whole square of d plus 2 of e power minus 2x. So if we replace d for minus 2, the value will be 0. So you first operate e power minus 2x with 1 by d minus 1 whole square and then operate with 1 by d plus 2. I am writing first e power minus 2x. This is the given function and we have to operate with 1 by d minus 1 whole square. So we know how to operate it by shorter method. Just replace d for minus 2. Here a is equal to minus 2. 1 by d, in place of d I am writing minus 2 minus 1 whole square. It is e power minus 2x because it is not equal to 0. When you replace d for minus 2, the denominator is not equal to 0, then the solution will be e power minus 2x by f of a only. That is 1 by d plus 2 of e power minus 2x by 9. This is minus 2 minus 1 minus 3 whole square, that is equal to 9. Now 1 by d 9 of 1 by 9, here I will write what this is, 1 by 9 into 1 by d plus 2 of e power minus 2x. That is 1 by 9 into, if we replace d for minus 2, this is 0. If we replace d for minus 2, this is 0. And this is of the form d minus 2, d plus 2. So d minus alpha, d minus of minus 2, like that. So what we can write, it is like 1 by d minus of minus 2 e power minus 2x. If we replace d for minus 2 plus 2 will be 0. Then what is the formula? Whole power k. This is whole power 1. X power 1 by 1 factorial into e power minus 2x. Right, very clear? 1 by d minus a of e power ax log. Here a is minus 2. If we replace d for minus 2, then it will be 0. 0 means what formula we have to use? X power k by k factorial into e power ax. Here k is 1. So x power 1 by 1 factorial into e power minus 2x. So the value I am writing x by 1 factorial e power minus 2x. This is called the particular integral of the given problem, d minus 1 whole square of d plus 2 of y is equal to e power minus 2x. Now the solution will be the sum of the two values. This is complementary function 1 and particular integral 2. The solution will be y is equal to the complementary function c1 e power minus 2x plus c2 plus c3x of e power x plus, this is all complementary function. And here 1 by 9, the value x e power minus 2x. This is the complete solution of the given problem. Right, all of you? So if e power ax, we use this approach, the above said procedure we have to. So last problem in this model, I would like to solve this also because it is cos hx. So cos hx, what I can write? Cos hx is equal to e power x plus e power minus x by 2. Cos hx also can be represented in the exponentials as e power x plus e power minus x by 2. That means you can follow the shorter method of finding the particular integral, that is e power ax model. So as usual, I will solve this equation by considering f of d is a d square plus 4d plus 5. The auxiliary equation is m square plus 4m plus 5 is equal to 0. Or I can write m square. What are the roots of the equation? I can write 5m. How I can write the equation? m is equal to minus b plus or minus root of b square minus 4ac by 2 into a. It is minus 4 plus or minus 16 minus 20. That is 16 minus 20 means minus 4 by 2. That means what? Minus 4 plus or minus 2i by 2. So this is minus 2 plus or minus I. Am I right? Here, see the equation m square plus 4m plus 5 is equal to 0. The roots are minus b. Minus b means minus 4 plus or minus root of b square 16 minus 4 into a means 1, c means 5. That is minus 4 plus or minus root of 16 minus 20 under square root 16 minus 20. That means it is minus 4. So minus 4 plus or minus root minus 4 by 2. Minus 4 means root under square root, it is 4i square. On writing outside you will get 2i. 2i by 2 or on cancelling out 2 in the numerator and denominator, minus 2 plus or minus I. So therefore what is the complementary function? The complementary function or yc is equal to e power minus 2x into c1 cos x plus c2 of sin x. This is the first part of the solution. Call it is equation number 1. Here alpha is equal to minus 2 plus or minus beta x. Alpha plus or minus beta x, I beta notation. Alpha plus or minus I beta means alpha minus 2 e power alpha x into c1 cos beta is equal to 1. So c1 cos x plus c2 of sin x. This is the complementary function of the given problem. Now, to find the particular integral, yp is equal to 1 by, what is the function? D square plus 4d plus 5 of 2 cos hx. So cos hx is replaced by, how I can write? D square plus 4d plus 5 of 2 into cos hx means what? E power x plus e power minus x by 2 or 2 to cancel. It is 1 by d square plus 4d plus 5 of e power x. And also I am splitting also here. And the second function 1 by d square plus 4d plus 5 of e power minus x. Now substitute x value, d place, in place of d substitute 1 here. Then e power x by 1 square plus 4 plus 5. Just replace for d for 1. Then 1 square plus 4 into 1 plus 5. Clearly it is not equal to 0. And the second one is e power minus x by d square minus 1 whole square plus 4 into minus 1 plus 5. Then what will be the value? E power x by 9 plus 1. This is equal to 10. And e power minus x by minus 1 whole square plus 1 plus 5 minus 4. That is 6 minus 4, that is equal to 2. This is the particular integral yp. So here all follow the first case only. Because it is the denominator is not equal to 0 in both the terms, the value is e power ax by f of. Therefore, the complete solution. What is the complete solution? Here, y is equal to yc plus yp. That is, y is equal to e power minus 2x of c1 cos x plus c2 sin x plus e power x by 10 plus e power minus x by 2 is the required solution of the given differential equation. So in this way, we can find the particular integrals of f of d into y is equal to f of q of x, where q of x is equal to e power ax. Not only e power ax, if it is 1, we consider it is e power 0x. If it is some constant, we write it as some constant into e power 0x. If it is sin hx, then e power x minus e power minus x by 2. If it is cos hx, e power x plus e power minus x by 2. So, like the function e power ax, cos hx, sin hx, and constants, we can approach this method. To find the particular integrals. So instead of using the conventional method, we go for the shorter method. Similarly, I would like to see the type 2 model. So what is type 2? finding the particular value or particular integral of f of d into y is equal to q of x, where q of x is equal to either sin bx or cos bx. This is second model. In the first model, we have seen f of d of y is equal to e power ax notation. In the second model, f of d of y is equal to cos bx or sin bx. If any function is there on the right hand side, we can approach this model. This is also shorter method to find the particular integral when the right side function is either in the model of sin bx or cos bx. So here the working rule, how to find the particular integral. So yp is 1 by f of d of sin bx or cos bx. So in this model, first we have to write the denominator as a function of d square notation. So there should be a d square term in the denominator. To substitute d square, instead of d square we have to replace minus d square. So to make the denominator as a function in the terms of d square, we multiply and divide with the same function and make the function as a function of d square. That is the first step. First we have to make the f of d as a function of d square, that is like phi of d square. Then replace d square by minus b square. Replace d square by minus b square in phi of d square. If phi of minus b square not equal to 0, if the denominator is not equal to 0, then the value, what is yp? Yp is equal to 1 by phi of minus b square of sin bx or cos bx. There ends the particular integral. If you replace d square by minus b square, if it is not equal to 0, then the particular integral is very simple. Sin bx or cos bx by phi of minus b square. There ends the problem. Yp over. Suppose if phi of minus b square is equal to 0, if you replace d square by minus b square, and suppose if the value obtained is 0, then if it is in the form 1 by d square plus b square of sin bx, then the value is equal to minus x by 2b cos bx. So please remember, when it is sin, it is minus x by 2b cos bx. When it is cos, this is plus sin bx. So we have to use the formulas 1 by d square plus b square of sin bx is equal to minus x by 2b of cos bx. If 1 by d square plus b square of cos bx, then it is x by 2b of sin bx. So these formulas has to be applied when the function of minus b square is equal to 0. If function of minus b square not equal to 0, then there is no complexity. Just you write sin bx or cos bx by phi of minus b square is the required particular integral in this case. So to get more clear, we will go with one example and I will show that. And here I would like to work out this problem. D cube minus 1 of y is equal to cos 3x. So the right side is in the form cos bx. So then we can apply the shorter method of finding the particular integral of type 2. So in any problem, we have to find the complementary function as usual. So here what is f of d? Here f of d is d cube minus 1. Now to find the complementary function, I write the auxiliary equation is m cube minus 1 is equal to 0. So m cube minus 1 means m minus 1 into m square plus m plus 1 is equal to 0. So on multiplying, you can check it out. M cube minus m square, plus m square plus m minus m square minus m minus 1, 0. These two cancel, it is still m cube minus 1 is equal to 0. So writing in factor form, m minus 1 into m square plus m plus 1 is equal to 0. So m minus 1 is equal to 0 is one factor. So m is equal to 1 is the one root of the equation. For the second one, m square plus m plus 1 is equal to 0. The roots are m is equal to minus b plus or minus root of b square, 1 square minus 4ac by 2 into 1. Or I can write it as minus 1 plus or minus 1 minus 4, that is minus 3 by 2, or minus 1 plus or minus root 3 I by 2, because I square is equal to minus 1. I'm writing I square outside, we will get I. So what are the roots? Minus 1 by 2 plus or minus root 3 by 2 into I. So what is the complementary function here? Therefore, the complementary function or yc is equal to c1 e power x for real root. One is one root of the equation. One is the root of the equation. So c1 e power x for first root. And for the second root, e power minus x by 2 into. So here alpha. This is alpha plus or minus I beta. Here alpha is equal to minus 1 by 2 and beta is equal to root 3 by 2. So the form will be e power alpha x into c1 cos beta x plus c2 sin beta x. This is the format. So here alpha we know that, beta we know that, e power minus alpha x. So e power alpha x means what? E power minus x by 2 into c1 cos root 3 by 2x plus c2 sin root 3 by 2x is the first part of the solution, which is called the complementary function of the given differential equation. Now we have to find the particular integral. Complementary function as usual in each and every problem we approach the same methodology to find the complementary function. But particular integral is different. Based on the right hand function, we have to apply different methods. So here, what is yp? The yp is 1 by d cube minus 1 of cos 3x. 1 by f of d. See this previous slide? Here f of d is d cube minus 1. So 1 by f of d of cos 3x. Now, replace. So I can write this as the denominator as d into d square minus 1 of cos 3x. Am I right? Now what we have to do is, in this model, replace d square by minus b square means minus 9. Here b is equal to 3 because it is cos bx. Here b is equal to 3 and replace d square by minus b square, not minus b whole square. We have to use minus 3 square or minus 9. So on replacing d square by minus 9, what we will get? D into minus 9 minus 1 of cos 3x. We are not substituting anything instead of d. We are substituting just wherever d square you find, d square or d power 4 or d power 6, like that. Then you will get d square. Instead of d square, you can replace by minus 9. So then what we will get here is 1 by minus 9d minus 1 of cos 3x. Now this is a function of d only. This is capital D. This is a function of d only. Now make this as a function of d square. So I will rewrite this as 1 by 9d plus 1. And taking out minus sign, we will get cos 3x. Am I right? 1 by 9d plus 1 minus taken outside cos 3x. Now we cannot substitute d for 3. That is not the method. We have to replace d square by minus b square only. So to make this as a function of d square, I multiply and divide with 9d minus 1. I am multiplying 9d minus 1 and I am dividing with 9d minus 1 the function cos 3x as it is. So I am multiplying minus inside 1 minus 9d by, this is what, 81d square minus 1 of cos 3x. It is looking like a plus b into a minus b. A square minus b square. 9 9s are 81, d square minus 1. So now it is a function of d square. Now what we have to do is replace d square by minus 9 again. So already we have substituted d square by minus 9 in the initially. So here also we make this as a function of d square and replace d square by minus 9. Then what we will get? 1 minus 9d by 81 into minus 9 minus 1 of cos 3x. So what is the constant in the denominator? 81 9s. 9 1s are 9, 9 8s are 72. Minus 72 minus 730. 1 by 730. 729 this is. 9 1s are 9, 9 8s are 72. Minus, already minus 1 is there. Minus 1 by 730. Remaining here 1 minus 9d of cos 2x. Cos 2x or cos 3x? Cos 3x. 1 by minus 9d of cos 3x. So how to operate this? 1 by, so I will write here in the next slide, this is equal to minus 1 by 730 into 1 minus what it is? 9d of cos 3x. So minus 1 by 730 into, now operate 1 of cos 3x. 1 of cos 3x, that is cos 3x, minus 9 into capital D of cos 3x. Capital D of cos 3x. But what is D? D means d by dx. So d by dx of cos 3x. What is d by dx of cos 3x? The derivative of cos 3x is minus 3 into sin 3x. Am I right or not? Cos 3x derivative, sin 3x into 3 ki 3 constant will get, and minus sign also will get, minus 3 into sin 3x. So I'm substituting minus 1 by 730 of cos 3x minus 9 into minus 3 into sin 3x. Sin 3x derivative 3 cos 3x. Cos 3x derivative minus 3 sin 3x. So this is equal to minus 1 by 730 of cos 3x plus 9 3s are 27 minus minus plus of sin 3x. This is the particular integral, or we call it as yp. This is the second part of the solution. Minus 1 by 730 into cos 3x. So here minus minus plus 9 3s are 27 of sin 3x. Here 9 into d of cos 3x. What is d of cos 3x? Minus 3 of sin 3x. So therefore, the general solution is given by, what is the general solution? Y is equal to the complementary function plus particular integral. So what is the complementary function we obtained? C1, right here, y is equal to C1 e power x plus e power minus x by 2 of C2 cos root 3 by 2x plus C3 sin root 3 by 2x plus minus 1 by 730. So I can write it as e power minus x by 2 C2 cos root 3 by 2x plus C3 sin root 3 by 2x minus 1 by 730. It is the particular integral cos 3x plus 27 sin 3x. So this is the complete solution of the given problem, the complementary function plus particular integral. So in this way, we can find the particular integral when the right side function is cos 3x or sin 3x. So the general notation is cos ax plus b or sin ax plus b. In this notation, we follow, just replace d square by minus b square and we find the particular integral. So the general solution will be complementary function plus particular integral is the required solution of the given differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.